welcome back to my channel. Today we are continue with the chapter continuity with the exercise 5D. In this video we have discussed the continuity of the function of type f of x will be equals to g of x when x is less than a, and f of x is k when x will be equals to a, and f of x will be equals to h of x when k is greater than a. Now let us start with the questions of this type of this exercise. Now let us start with the first question. Question is, examine the continuity of the function f of x will be equals to 2x plus 1 when x is less than equals to 2 and 3x minus 1 when x is greater than 2 at x will be equals to 2. Now let us start. Firstly, we will given that the f of x is the function 2x plus 1 when x is less than equals to 2 and 3x minus 1 when x is greater than 2. Now we have to solve this function at the limit x approaches to 2 negative and then limit x approaches to 2 positive. That means left hand limit and right hand limit. F of x, it will become limit x approaches to 2 negative 2x plus 1. This is the function at left handed limit because x is less than equals to 2 and here be the function x is greater than 2. That means limit x approaches to 2 positive 3x minus 1. Now here we have to put x will be equals to 2 minus h where h is greater than 0 so that h approaches to 0 as x approaches to 2 negative. Then we get limit h approaches to 0. Here we have to put x will be equals to 2 minus h plus 1. It will become 4 minus 2h plus 1 at limit h approaches to 0. Then we get limit h approaches to 0 5 minus 2h. Now we have to put the limit h will be equals to 0, then we get 5. Now we have solved this limit, then it will become, here we have to put x will be equals to 2 plus h where h is greater than 0 so that h approaches to 0 as x approaches to 2 positive. Then here we get the limit h approaches to 0 and here we have to put x will be equals to 2 plus h minus 1. Then we get limit h approaches to 0 6 plus 3h minus 1 which will become limit h approaches to 0 5 plus 3h. Here we have to put the value of h, that means 0. Then we get it will be equals to 5. So function at x will be equals to 2, then the value will be equals to the value of 2x plus 1 at x will be equals to 2. That means now we have to put x will be equals to 2 here, then it will become 5. So the function at x will be 2 equals to 5. So therefore limit x approaches to 2 negative f of x will be equals to limit h approaches to 2 positive f of x. That means left handed limit will be equals to the right handed limit. So therefore the function f is continuous at x will be equals to 2. So the given function is continuous at the point x will be equals to 2. Now next question is, find all the points of discontinuity of f where f is defined by the function f of x will be equals to mod of x plus 3 when x is less than equals to minus 3, and f of x is minus 2x when minus 3 is less than x is less than 3, and 6x plus 2 when x is greater than equal to 3. Here the function f is defined all the points of real line. So firstly we will have to let c be any real number. So now we have 5 cases for solve this question. First case is when c is less than equals to less than minus 3. For this we have to take the limit x approaches to c f of x. That means for this case function is this, that means limit x approaches to c mod of x plus c. Here we will have to put the limit, then we get mod of c plus 3. That means f of c will become mod of c plus 3. So therefore the limit x approaches to c, f of x will be equals to f of c. Now, so therefore the function f is continuous at all the points x is less than minus 3. Now second case is when c will be equals to minus 3. Then when c will be equals to minus 3 we will have to take the limit x approaches to c negative f of x and limit x approaches to c positive f of x. That means left hand limit and right hand limit. Then it will become limit x approaches to minus of 3 negative and f of x is box of x plus 3 mod of x plus 3. Then we have to put the limit, then we get mod of minus 3 plus 3 and mod of any term will become positive, so we get 3 plus 3, it will become 6. Now we have to solve this, that means limit x approaches to minus 3 positive and f of x is minus of 2x for right handed limit. Then we have to put the value of x, then we get minus 2 into minus 3, it will become 6. So therefore the limit x approaches to c negative, f of x will be equals to limit x approaches to c positive f of x. So therefore the function f is continuous at x will be equals to minus 3. Now third case is when minus 3 is less than c is less than 3, then function f of x will be equals to minus 2x, which is the continuous function because it is always a continuous function because as it is a polynomial. Now in the fourth case c will be equals to 3. For this we have to solve limit x approaches to c negative and limit x approaches to c positive f of x. Then for this we have the function limit x approaches to 3 negative minus of 2x, and for right handed limit we have the function limit x approaches to 3 positive 6x plus 2. Then we have put the limit, then we get minus 2 into 3, that means minus 6, and here we will put the limit, then we get 6 into 3 plus 2, that means 18 plus 2 we get 20. So from these two, limit x approaches to c negative f of x is not equals to limit x approaches to c positive f of x. That means left hand and right hand limit are not equal. If these are not equal, therefore the function is discontinuous at x will be equals to 3. Now case 5, which is the last case of this question. In this we have to solve c is greater than 3. Firstly we will have to solve 3 is less than minus 3, then c will be equals to minus 3, then minus 3 is less than c is less than 3, then c will be equals to 3. Now we have to solve c is greater than 3. For this we have to take the limit x approaches to c f of x, that means we get limit x approaches to c, function is 6x plus 2 for x is greater than 3. For now we have to put the limit x will be equals to 3, then c we get 6c plus 2. So therefore f of c will be equals to 6c plus 2. So therefore limit x approaches to c f of x will be equals to f of c. If these are equal, so therefore the given function f is continuous at all the points x is greater than 3. So these are all the cases of all the points of discontinuity of the given function f. So hence proved. If you like my video, then please like, subscribe and share my videos, and do not forget to press the bell icon for the notification of the more videos. Thanks for watching.